Okay, so what we're going to do here is we are going to find sines and cosines of special angles. All right, so we've talked a bit about special angles already in other videos, but we'll get more into it right now. Okay, so let's talk about finding sine of 45 degrees and cosine 45 degrees. And there are different ways to do this. So I'm going to do this using a unit circle approach. Okay, up here, as I'm showing, is 90 degrees. And, you know, this is, for the most part, I'm always doing unit circles, even if I don't label that. Okay, half of 90 will give 45 degrees right here. Now, it's maybe best if I put the 45 up here at 45 degrees. You can put them both ways, but all right. Now, what we can notice about what we do is we draw a right triangle here. So we drop a right triangle to the x-axis. It's always to the x-axis. And what I'm going to do is start sort of fiddling around with this right triangle here. Now, the thing is that what we need to do is observe that for 45 degrees, the x and y are both the same. The x and y coordinates are the same. And there's more to it than that. I mean, I'm making a right triangle. And so here I'm putting 45 degrees. I'm copying this over here and just using the fact that these angles have to add up to 180 degrees. There's a 90 degree angle, and therefore these two have to both be 45 degrees. And since these angles are the same, 45 and 45, the sides opposite must be the same. Let's call those A. So it's an isosceles triangle. And then I can use the Pythagorean theorem. Or you can also use the Pythagorean identity. But let me just use the Pythagorean theorem. So I'm breaking down and using triangles. And now I have a little problem that I don't have enough space here. Okay, but anyway, I have a squared is 1/2. And then when I take the square root of both sides, I'm not going to do plus or minus because I'm dealing with a triangle. I'm looking at lengths. Okay, and so therefore, if I fit this in here, a is equal to 1 over the square root of 2. So our triangle that corresponds to 45 degrees, it's a right triangle, and hypotenuse 1 has these sides 1 over square root of 2 and 1 over square root of 2. Now, some books are okay with, they like writing it this way, but it's also pretty common that people like to rationalize the denominator, which I think everybody, well, I don't know if you're familiar with that, but you can do that. And this becomes rad 2 over 2, rad 2 over 2. So back to our picture then, we can go up here, fill it in, or we can rewrite one. For 45 degrees then, I have the x-coordinates rad 2 over 2 and the y-coordinates rad 2 over 2. Why? Because of the fact that the 45 degree angles right here in that right triangle, which we call a 45, 45, 90 triangle. So that 45, 45, 90 triangle fits in right here, as shown. And so therefore, cosine 45 degrees is equal to rad 2 over 2. Sine 45 degrees is equal to rad 2 over 2. And, or maybe I should say or just, let's not say either of those things. We have that if you're doing radians, pi over 4, cosine pi over 4 is rad 2 over 2. Sine pi over 4 is rad 2 over 2. Why? Because 45 degrees corresponds to pi over 4. If we draw a circle, unit circle, all the way around once is 2 pi. 1/4 of that is pi over 2. So pi over 4 is half of that. Okay.